100-ton bollard pull, depending on what type of rig we are on. If I have a flat bottom tender, like one of my Sapura T10s or Sapura T9s, I'll be towing it with a 100-ton bollard pull vessel. For a semi-sub like which was the Sapura Esperanza, that's the rig that I'm on right now, Sapura Esperanza. If we were to tow this, I would use a 120-ton bollard pull vessel on a tow bridle, and we would tow. But the thing is that I would limit our risk to our crew, risk to our vessel, risk to our tow lines. We would mitigate the risk by floating the rig onto a heavy lift vessel. So what I would do is we would take it on. Why don't I show you? Okay, let's see something. Give me a minute. Okay, so I'm going to share a. Can you let me know if you can see my screen?
Not
Can
yet.
you see my screen? Not yet, right? Okay, just give me a minute now. Let me just share screen. Can you see my screen? Okay, so I'm going to share with you what this is a.
Okay.
Okay, so this is a heavy lift vessel, or a what do you call? It itself is a semi-submersible heavy lift vessel. So on top you see something from CCCC or Costco. This is a and then this is from Dockwise. This is from OHT. These are some of the operators of these heavy lift vessels. So what happens is we would take our vessel, our rig, and then this is a flat bottom tender, as you can see at the bottom. Flat bottom meaning it doesn't have any underhangs and all that. We also have semi-submersible drilling tenders, which is a column stabilized unit. Stabilized unit means I have a pontoon, 6 legs, and generally we float on this water. So what happens is we have to bring this onto a heavy lift vessel, and what we'll do is we will need to do some preparations, sea fastenings, and this is how we do it. So myself and a few other rig movers, we would go on these heavy lift vessels. We would man ourselves on either of these vessels. One guy will be stationed on the HLV itself. On the semi-sub itself, and we would tow the rig there, disconnect the harbor tugs, and push it in after we have connected the lines from the HLV. So this itself is a very interesting concept. We have several guidelines we put ourselves in to make sure that the rig is straight. And once we put there, we would position our key personnel on these heavy lift vessels. Have a team of who stands where, who does what. Brief everyone of the operations, and then once we are there, we will put the vessel onto the HLV. It will then be secured with lines. Once it's secured with lines, they will and sit on. They will float up and deballast and float up, and the rig will sit on it. Once it sits on it, we will have the sea fastening, warranty surveys, and all that put. So that's one of the HLV operations that we do. Wet tow, dry tows.
So the rig mover, I mean the duty as a rig mover like you, are stationed on board the platform or one of the 4 tugboat?
Okay, so rig movers are usually on the drilling rig itself. So what we do is we station our drilling rig. If we are going into operations with clients like Shell, JX Nippon, Petronas, CNR International, those major oil players, right? What they'll do is they will have a survey team, a survey system and survey team which has DGPS, its own gyro systems, screens, the field charts, the pipelines and everything. We would have that on a screen. So it will be stationed in the ballast control operator's room or the radio room, depending on which type of rig we're on. Using that, we would run our anchors. We will have an anchor handling plan, a rig move procedure that has already been agreed by the council or the the rig move meeting prior, and we would get into position. And what the rig mover does is we will be talking to all the boats that are involved. We would bring the rig into position, run the first anchors, second anchors, third anchors, fourth anchors, and if there are any wires that will go over pipelines, we would install. So there's a process to all of that, and we are there to manage the safety and the process of the whole rig move organization.
See. Okay, Cap, we can continue your presentation regarding other operations.
Yeah. Okay, sure. So what I'm going to share now is, you can still see my screen, right?
No.
Not yet, huh? Okay, sorry. Let me just share
this.
Now, okay. So I am going to go with, okay, this is what an offshore Okay, that was a sharing on what
Cap,
I would.
previously
Yes.
Sapura Energy known as Sapura Kencana, is it? Or it's different
Okay,
entity?
that's a good question. All right, so what I'm gonna do is I'm gonna do a little quick sharing on how this company started and what type of history it is.
Okay.
What you see today, for us, for the offshore rigs, right, and this division where drilling is concerned,
Mhm.
we have a near 40-year history, 40 years of history. So originally, it started off way long ago in 1970 something with Robin Shipyard. Robin Shipyard built the first Rob Ray T1, T2, T3. Rob Ray T1, T2, T3s were in the 70s, drilling in Egypt, in the Middle East, in the Red Sea. It's a long time ago. So what happened was after that, in the 80s, in the 90s, T3, T4 came about, and it gathered the Norwegians took interest in this little Singaporean company. Rob Ray was a Singaporean company. Then the Norwegians took notice of it, and Smedvik came up and started taking over, and we built the T3, T4, T5, T6, T8, T9 Technic Burkhardt. And in its expansion, they absorbed another company called Petrodrill. So Petrodrill was the one that T3, T4, T5, T6 were all flat bottom barges. We're talking things that look like accommodation barges with drilling packages with 2 cranes. Those were flat bottom barges that came up first. In 1993, there was a company called Petrodrill. Petrodrill came up with the concept of, hey, why just do the flat bottom barges? Let's use the semi-submersible drilling, semi-submersible concept where we can work in deeper waters, rougher water, more robust type of environment. And we do this drilling thing, and we build. So they had a contract, a very built for Brunei Shell Petroleum. So that was the Sapura Pelaut, the one that you saw the video. That was my rig. So in 1993, 1994, that came up. And with that, it was in Far East Livingston Shipyard in Singapore, which is now known as Keppel FELS. It was a success. They improved on the idea, and came the Menang, the Alliance, the Setias. So Smedvik took interest in that, absorbed Petrodrill. We became one big Smedvik with flat bottom tenders and semi-submersible drilling tenders itself. And come down to about 2006, there was a big upheaval in the Norwegian drilling companies. A new player came in. It had a lot of backing from a lot of powerful people. The owners were very big what they call shipping contracts and all that. That was known as Seadrill. So Seadrill bought over Smedwick. Smedwick itself was originally a cannery fishing company, which went into drilling, and Smedwick became Seadrill. So in the 2006 all the way to 2012, we built a few more rigs, 5 more rigs. We had the Vincedor, the Jaya, the what do you call it? The Satya Jaya, Vincedor, Esperanza. The expansion was big and fast. And in 2012, what happened was what we think is, hey, it was bought over by Sapura. But actually within this entity itself, right, back in 1993 all the way till now, we've always drilled in Malaysia under the name Tioman Drilling. So if you heard of Tioman Drilling, we're all the same company again. Tioman Drilling has always been inside. Sapura Kencana with Mermaid, they gabong together, they came in and we became Sapura Kencana Drilling. Now under Seadrill, right, it was an even bigger outfit. Under Seadrill, there was tenders, semi-tenders, there was jackup, there were drill ships. So there was a gigantic company at the time. And in 2012, what happened was the Sapura Kencana Drilling with at that time Mahathir's son's company was Kencana and Sapura, and then they bought over the 1/3 of Seadrill. There was an exchange of directors. There was an exchange of drilling units. We took over a gigantic 1/3 of, and we became Sapura Kencana Drilling. And I think a couple of years back, we rebranded Sapura Drilling Asia under the new Sapura Energy Berhad banner. So while there was many years of many people taking over names, we've changed names so many times, from Palau to West Palau to Sapura SKD Palau to Sapura Palau, you know. But actually, our people are the same people. We are just changing coveralls, but we are from the same history. So there are many of us from which carry a legacy of 40 years of knowledge, experience, drilling capabilities, reputation. So therein, that's our short history. I open the floor if you have any questions on Sapura Drilling or drilling operations. If not, then we will move on to the next topic, which is
maybe the participants want to ask any question regarding the history of Sapura or any other question regarding our previous slides or operations, maybe before we proceed with others topic. Any questions from participants? I saw some of okay, it's okay.
How about the breaking stress of towing line? Okay. Muhammad Hafiz to everyone. Okay. So let's talk about the breaking stress and towing line. So what we have in the Marine Ops manual of every vessel, right? They have calculated the displacement. They have calculated with the towing calculation. What they have done is they come up with a resultant towing curve. So what happens is in order to understand the capabilities or the vessel that you want to select, I will be looking at the towing curve of the vessel. You can either do a what we call a Bollard pool study, or you at the end of the day, the opposite way is to have them incorporate that into your Marine Ops manual. And what you will see is a towing curve. The towing curve will say at what speed, this is the Bollard pool, or this is the stress and the braking load that will come onto the lines. So you must be curious, at what speeds do our rigs tow on? For wet tows, we will be towing on about 3 to 4 knots. And on dry tows, we will be towing on about 9 to 10 knots. So it's nearly 1/3 the speed if you are towing by wet tow, and it's 3 times faster if you're towing by dry tow. Nearly 3 times faster. Hence, What's the question you want to know about the breaking stress and the type of towing line? Hafiz Saleh, who is Hafiz Saleh? Is there anything that you want to know about that? What type of lines we use?
Cap, maybe like vessel, we always refer to OCIMF Mac 4 for the mooring line breaking stress and so on, right? The safety limit for the mooring breaking stress and the mooring line breaking stress.
Okay.
How about in offshore industry? Which reference? I mean, which guidelines they are referred to?
Okay, so in our type of operations, right, I will share with you guys industry-wise so that you can see what is there for us. I'm going to share my screen. Can you see my screen? Not yet, right? I haven't.
No, yeah,
right.
I believe
Okay, so
some delay.
just give me a minute. Let me just open up the Marine Ops manual first. Okay, so 12.2. Give me a minute. Let me get to the
just
section.
now you mentioned about the wet tow. The speed is 3 to 4 knots, is it? The wet tow or the dry tow?
Wet tow. Okay, just give me a minute. Let me get to the towing curve. Okay, I'm going to share screen with you now. Just give me a minute. Share screen. Can you see my screen?
Okay, got it.
Okay, so what you see here is this towing curve. This is a Marine Ops manual of the rig that I'm currently on. So what happens is you can either do a very big study and then down the calculations and you get a towing curve, the tow line pull in kilonewtons versus the speed in knots. So when you know your speed in knots, generally you know that you're pulling approximately about 60 tons. So when you select a vessel or when you select a line, right, you say, okay, I know that I'm going to be towing at about 3 to 4 knots. I know that I'm going to be using about 60 tons. I cannot choose a 60-ton bollard pull vessel. Why? Because when you say a bollard pull test, right, a bollard pull test is done on calm water scenario, in the port scenario, where he's using all his engines, all his load, all his power, without counting on the effects of sea, without counting on the effects of wave. It's just pure power on the vessel. Now, when you're towing, right, you know that you're going to use about 40 to 60 tons. You cannot go say, I'm going to choose 60-ton vessel limit. Because when the seas come up, suddenly force 3, force 4, force 5, force 6, and you have waves, 2-meter waves, 3-meter waves, you no longer can perform. You are at the mercy of the sea. So for my type of vessel, right, the flat bottom tenders, I would go at 100 tons bollard pull. And for a semi-sub, I will go at 120-ton bollard pull. So what I have is when I'm towing at 3 knots, I have this much redundancy. I have this much redundancy in bollard that the vessel can churn out in case the sea is against us, the vessel is against us. I can still have him come up to 80-90% power, and we can still make the target for the ETA. Okay, generally we tow at about 70 to 80%, 85% RPM. For vessels, right, you can maintain a steady high RPM. What you avoid you are selecting RPM for vessels is you avoid their resonance. They have these resonance sections where everything starts to menggegar due to the natural frequency of the vessel. So at certain engine power, they say, okay, at 90% or something like that, or 70%, below this percent, this frequency is bad for the vessel. So they will say you can go up to here or you can go beyond here, but never in this range where it's resonance. So for that, right, what we do is we can, for vessel is no problem with maintaining 85 tons, 85% engine power over a long period of time. To them, it doesn't affect, you don't have to like car like that, or go up high gear, go up low gear, high gear, low gear. You can maintain, tweak up to a certain RPM and it will stay. So for me, when I'm towing in field or up to 14 days in the ocean, ocean tow, I call it, I would use about 120-ton bollard pull to pull a semi-sub, 100-ton bollard pull to pull a flat bottom tender. Unless you want to see configurations of the towing line. But generally, this is what you choose. You see the tow resistant curve, you see the speed that you're going to go on, and then you see the line. So what I would select is, if I know that my line is going to be at 60 tons, I will go for higher MBL. The MBL of the wire may be 300, 400 tons, but I'm only going to pull a line tension of 30, 40 tons here. So vessel, you have redundancy. Line, you have redundancy. Safe working load, you have redundancy. MBL, you have redundancy. You know that you're not going to reach the maximum limits. Also, for that reason, we do not go on long tows beyond 14 days. Why? Let's say if I'm towing to Africa, would I choose a wet tow or would I choose a dry tow? What is the considerations to consider? For the safety of crew, right? If I am doing a dry tow, I would empty the rig when I am floated on. I will shut the rig down, completely shut the rig down, leave 2 men on the HLV, and they will do the safety rounds and all that. So when it travels at 9 knots. It's a economical, what do you call, vessel speed. And it has its crew and all that, and we become just cargo. When we arrive in location, we would man up the rig, start up all the engines and all that, get it floated down, and we float off, and we will go and run our anchors or get towed to the next location by wet tow. That itself covers 5,000 nautical miles. So can you imagine if 5,000 nautical miles for normal conventional HLV vessel is already ace. If I were to do it with a slow tow, it would take 150 days. Then I have to talk about crew, I have to talk about manning, I have to talk about refueling, I have to talk about restocking up food. It doesn't become economically nor safety-wise, you know. If you're going to pass the Cape of Good Hope and you are using the sea fastening, what do you call it? We use DNVGL standards for ocean tow. You have to be able to withstand up to 10 degrees roll. We are calculating and warranty surveying up to 10 degrees of roll. So if we are doing wet tow, right, your stresses when you're going through the ocean, cross-continent, it's beyond the capability of the rig, and it's beyond the risk of putting crew and the rig on. In certain areas like Straits of Malacca, like Straits of Singapore, even the Straits of Singapore itself, right? You have counter currents, you have the tidal streams that go up to 2 knots, 3 knots. So if you were to see the plot of the rig moving, it would be like dot 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 dot. At certain times you're going backwards because the current is faster than the tow capability of the vessel, the displacement wise, the power wise, and all that. So if you are saying 3 knots is on good day. You can go with the current with you, you can go 4.5 knots. With the current against you can be down as slow as 2.5 knots. In that type of scenario, I wouldn't go 5,000 nautical miles. And on top of that, when we are a drilling rig being towed, a vessel doing a tow job, you also have to talk about insurance, warranty survey, insurance underwriter reporting, suitability of tow surveys, and all that. So all these reporting channels, right? The longer you put the tow, it may incur insurance. What do you call it? They call it insurance premiums. 4% of the insurance, 4% of extra premium. When we talk about the premium price of the rig itself is nearly $240 million. $240 million, $140 million. When you say 2%, 3%, suddenly you have to pay $500,000 US for insurance. So going by those rules, you have to select the most optimum cost versus risk versus whatever that you are given, your specs of your vessel in order to do the tow.
Okay, Kat, shall we proceed with other parts of your presentations?
Yes. So yes, we are using towing wire. That is correct. We are using towing wire. So the rig itself, we have on our pontoons, Smith brackets with chain. Do you all want to see? Do you all need to? I'll go with it's Smith brackets with chains, chain then to wires to a towing bridle, and then a forerunner that is wire. So generally, our towing lines are all wire. We do not go with mooring rope. Mooring rope is not accepted for long tows. Only within harbor you can use mooring ropes to tow. Yeah.
I see.
Okay. Is there any other questions on towing, or I will bring you all to something called hazard identification for safety? So generally, when you're in a drilling project, in order to get into the client's, the client will host something something called a pre-remove meeting, or a hazard identification meeting. What happens is they will call persons from HSE, marine, drilling platforms. Do Sapura Energy have their own towing operation? Okay, I'll come to that question. So when they're going to do an activity, right, what happens is they will call in a quorum of people, various disciplines of expertise. In this expertise, what they'll do is they will open up a table, what do you call it, an Excel sheet, and list down the steps of items that they need to carry out. Okay, we're going to do this activity. What are the risks for a move activity? These are the breakdown of the steps that we're going to do. What are the hazards that are going to be there? What are the existing what do you call it, mitigations that
mitigation?
Is it sufficient? What is the risk rating? What is the design? So it's a hazard it by itself. And if it's not enough, they will come in. Everyone will be peppering in. There will be a host, which is a HSE guy, and then with this formal qualitative risk assessment, they would note down what other measures need to be carried out. I mean, it is not just the rig move itself. It could be simple things like work permits. Are the crews requiring crews from Malaysia entering Sabah waters need to have Sabah work permit? Will there be any showstoppers? Example for the recent things in Malaysia are like COVID. If you say there's a COVID measure, are there any quarantine requirements? Are there any other special requirements? Do they need to have what we now call the industry, we call bubbles? In order to enter a bubble, you need to quarantine yourself into a bubble. 14 days quarantine, swap. After that, you come out, you go into a bubble. After you get into this bubble, you cannot mix bubbles. The platform is a bubble, the rig is a bubble, the vessels are a bubble, and you cannot mix these bubbles. So there are things like this that are also discussed in these rig move meetings, hazards and all that. Different expertise will come up with, I have a pipeline underneath there. Do you need me to shut down? This pipeline is live. When you do it, how soon do I shut down the platform? This platform is feeding the whole country. I cannot shut it down for how long? When do we shut down? When do we? To them, shut down is a bad word. So, but it's a necessary enemy, they call it. So what happens is they will try to tie in a lot of activities. If we're going to shut down for this period, what other activities can we do at this time? So when will you activate? How do I know that you're going to be on time? So we have to discuss all this. There will be a timeline of activities. Different divisions will come in, and then we would pepper in our expertise when they ask for our thoughts. That itself will go into the rig move meeting. Once that is done and that is finalized, formalized, all the risks have been advised. Vessel owners and captains are also invited into these meetings, because why? We also have to address the 24-hour crewing, 24-hour manning. Do you have enough experience? What is the endurance of your vessels? How soon do you need to clear out your vessels? What are the, what do you call, port clearance? Any other special permits? DSL, domestic shipping licenses. Do you have DSL for this? Are you a Malaysian chartered vessel? Are you under the Petronas umbrella of vessels? They will have a lot of questions like these. And then manning. Do you have 24-hour crew? Do you need DP mode? Who will do the DP test? do we need to have warranty survey on these vessels? So these are some of the items that will be, what do you call it? There will be some of the items that will be discussed in these rig move meetings. So now you already had the corporate version. Once you have finalized the corporate version, everyone has hashed out the thing. Okay, we are going to finalize who does this, who does that. There's going to be a table of follow-ups. Once everything is done, then we meet the council. The council is where the chairman of Petronas comes in, all the different divisions, high level comes in. Have you all done this? Have you all done that? Okay, what are the mitigations for this? What are mitigations for that? Who is going to take care of this? Who's going to take care of that? Everything is done. Okay, everything good. Then he officiates it. He says, I hereby approve this rig move to be carried out. What is the duration? What is the date? What is the cost? This and that. And they all finalize it. So once everything is finalized, they will still invite people like us, marine rig movers and all that. They will say, okay, what are you going to do in this activity? Can you please bring us through the plan? So I will go there and say, I will run this, I will run that, we will do this, we will do that. We need to reel in this, we need to spool in that. How are we going to put in, what are the mitigations that we're going to do and stuff like that? Do we need 24-hour manning? Do you have enough crew for this? Do you have enough crew for that? We will go through all this. Once that is all final, the council approves it. Then now it's time to say, okay, now you go on site. What are you going to do? So I will go to the vessel masters. I will go on board a vessel, call the crew together. I will brief them. Okay, these are the hazards that we have brought up. These are the steps. These are the procedures. These are the latest procedures that we've agreed on. This is the anchor handling plan. This is the rig move plan. These are the hazards that we need to look out for. What are the extra things that we need to look out for? I will brief the vessel itself. Every vessel that I go, I will inspect, I will brief. Then comes to the rig. When I fly to the rig, now I have to invite all parties together. So previously, before all these COVID measures, I would have everybody in a room. I would have the vessel masters in with the rig site, with the OIM, with the barge captain, with the marine rep from the Shells or the Petronases. We have everybody go through the last and we pen down the pre-rig move meeting minutes. We officiate everything. We go by, okay, this is the version of the procedure. This is the version of the anchor handling plan. These are the things that we need to watch out for. Okay, everybody, let's go around the table. Do you have any concerns? Do you have any concerns? Do you have any concerns? Everyone has already come up with their concerns. Okay, we are now ready to go. Now we execute the job. So when you execute the job, right, we go by a PBED model. We call it PBED. We have already done the planning. We have already done the briefing. Now we're going to the execution. So in the execution part, we monitor. We go through step by step. We do not deviate from our procedure. If we deviate from the procedure, we have to meet, what do you call, do a deviation plan. Deviation plan can be as simple as, okay, in order to make the deviation plan work, you have to have a quorum of people who acknowledge, accept the changes, go in the town, come back in. Is it necessary? And then approve and go forward. These are the type of operations that we do on site. So that's execution. So in execution, you make sure that everything goes safe, make sure that everybody has their hands in the safe place, go through the procedures, have people oversight on people, buddy systems, and everything is done. Once everything is done and executed safely, we have something called a debrief. A debrief is where we say, okay, what did we do wrong this time? What did we do well this time? What are the lessons learned that we can capture from this activity that can bring forward into the next activity? So we would have an after action review, formal after action review, which captures this is the good, this is the bad, this is what happened. Hey, this guy did this, this boat did that. It was an unsafe action. This was done really, really well. This boat was really, really good, or this process was really done properly. Oh, we cannot break the weak link this way. It is bad. It is unsafe. We tried and we damaged two things. Or these are the after action reviews that are captured. With this after action review, it will go into the next round when we do the hazard again for the next operation. They say, hey, we are going to have this quorum and we have this action. We are going to demob from this location. What did we learn from the last time? Oh, the hazards from last time was this. This is the after action review. What can we do better this time? So it becomes a formal cycle again, whereby we do the planning again to mitigate whatever that we debriefed in the last time. That itself is a cycle of rig move and anchor handling, which includes the vessels operations. We usually use, we work with midline buoys. Midline buoys are huge. What midline buoys does is we use clamps to clamp along the anchor wire to prevent it from sinking below and touching the pipelines. So there is an API RP. API is American Petroleum Institute. To certain standards, we keep these standards to make sure that it is it does not go below 10 meters, 20 meters of vertical depth distance. So there are rules for us whenever we plan an anchor pattern, like where can you drop an anchor? You cannot drop an anchor within how many meters of a pipeline. Pulling towards the pipeline, you have to be about 300-400 meters away. Pulling away from pipeline, you can be 100 and 200 meters away. So those are some of the considerations we put into engineering the safety and reliability of the vessel. Before we go into an operation, we also carry out something called a mooring analysis. So mooring analysis does is using your rig, using your shape of your rig, using the mooring lines of your rig, they calculate based on the environs of the location. They would analyze, okay, if the wind comes from this side, if the wind comes from this side, what is the environs that you can, what can you tahan, what can you not tahan, what is your weak link, what if you have one line failure, you know, what if you have one line failure from this direction, this direction, this direction, how far can you survive? At what point must you stop drilling and pull back into your safety zone? At what point must you leave your safety zone? What can your rig tahan in, what uproots your rig's moorings? These are all calculated into it. I will try to answer some of these questions in a while. We also have standard mooring integrity. Mooring integrity, we have API RP2I system. So, like when you talk about anchor handling vessels, towing vessels, you know, they are towing line and they are work wires. They seem to be able to use it forever. Oh, we just do a pull test and then but there is a limit. What limit are we talking about? When your braking stress, when your braking load, what do you call your braking load test exceeds 10% of your original MBL, that means if your loss of your strength of your wire is exceeding 10%, you should actually change your wire. So for us, similarly, we will also carry out API RP2I inspection on our mooring wires. When we carry out API RP2I inspection, what happens? We are looking at visual inspection of the wire for deterioration of wire. We're talking about diameter loss. We're talking about core damage or failure of the braking, 10% loss of MBL. Those are the things that are engineered into the safety of a rig platform project itself. Yeah, I'm going to answer Fatin's question. Does Sapura Energy have their own AHTS vessel when undergoing towing operation, or do you need to charter other vessel from another company? Okay, yes. Sapura Energy does have its own towing vessels. We have the Gemia and we have the Kapas. Kapas is a smaller one. Gemia is the bigger one. The 120-ton bollard pull, I think, is the Gemia. But same time, it's under a different company arm, and they do charter out themselves. So, or while we do have a courtesy query, we will call in the division. Hi, is Kapas and Gemia available? And then they say, no, Kapas and Gemia have a 2-year job in Myanmar. We cannot help you. So, okay, fine. That being done, we will go to our chartering division. We have something called the supply chain management. In order to, for big companies, right? In smaller companies, a person like me will be doing all this. You know, I will be doing the vessel chartering. I'll be doing the signing. I'll be doing this. But the thing is, in bigger companies, what happens is they have something called, this is conflict of interest. You cannot be also in charge of this, in charge of that. They want to prevent people from having corruption, anti-corruption policy and all that sort of thing. Why do you keep asking for this vessel only? So in order to prevent that, what happens is the supply chain management of a company will come up with, okay, in order to keep this clean level of involvement, SME means subject matter expert, you lay down your requirements. Supply chain management now takes these requirements, goes into the market and does a commercial bidding evaluation. On my side, I do a technical bidding evaluation. So when he gives me a list of vessels, I give him a list of what is my requirements. I will look at it and we compare. This one no good, this one no good, this one good, this one good, this one no good. And what I will do is I will look into websites like Equasys. Equasys is a website where they say, okay, this vessel has 2 black marks, what do you call port state arrest. I will look into things like that. And I would also engage a warranty surveyor to carry out suitability of pole survey if I'm chartering it myself, suitability of anchor handling survey if I'm doing the operations myself. And this becomes a layer of, what do you call it? A layer of acceptance. So we have the class, we have the warranty surveyors. So they will go there and inspect the vessel and say, hey, this vessel has not moved in the past 3 years and its engine got problem and it's missing something. So they will come up with that report. So my criteria usually for chartering, I will tell my chartering arm is that put it into the clause that if you do not pass the warranty surveyor's suitability of tow inspection, we cannot accept the tow. We cannot sign the charter. So for vessel owner, they would be very interested in, no worries, we'll help you get your warranty survey up. Please leave us a punch list when you go. So what happens is this, in order for him to do this job, he has a list of A, B, C, D, E, F, G. These are critical items. These are recommendations. These are things that we feel that you need to do in order to be accepted for the thing. So we would go back to them. Hey, warranty surveyor has this list. As long as you don't close this list, he cannot accept you. If he cannot accept you, I cannot accept you. And then if we cannot accept you, client cannot accept you. So these layers of what do you call that? Layers of protection for us, when we do it, then we have assurance. We have assurance that when we come into play, all we need to do when we go on board now is, okay, we've already done warranty survey, we've already done this and that. Now I do the final check, make sure everything is working before I start the operation. So I will go on board and I say, okay, let's bring your tow pin up, bring your tow pin down, do a brake test, do a emergency lowering test. I will do the physical test. Because why? The assurance of the engine, the everything that is looked at by, and maybe Ovid. Clients may also want to use Ovid as a standard. So what happens is Ovid is an OCIMF. They have a list of series of questions, and then the inspector go there and say, okay, in the past, right, Ovid was supposed to be a menu where clients say, I want to see what you have. In one eye, I can see what you have, or I can compare vessel to vessel using the same criteria to compare them. But over time, right, what's happened is the oil majors have seen this system and say, hey, quite interesting, huh? Why don't we use this standard? I want to make sure that vessels that I hire are all up to a certain standard. Ovid must pass. So now Ovid, instead of becoming a menu, has become a criteria of hire. So vessel owners, rig owners, different type of vessels, under Ovid they will have, oh, okay, do you have this, do you have that, do you have this, do you have that? And as long as you have the Ovid, they will have a punch list. You need to close out, you need to update the Ovid website. And what happens is when the Shells, Petronas, Exxons and all that, they as operators, they get to go into the Ovid website as operator and they can see everything about your vessel live. Hey, look at this. This one says the engine is spoiled. Anything is being done about it now. You know, so give you time to rectify. There, you will have to have your system to close out, checking, close out all these non-conformities, and you have to rectify it and update it into the website. So they will be able to see your track. Okay, they have done this, they have done this, they have found this, and they have done the repairs for it. So this vessel is quite good. It's got a full Ovid. The Ovid is valid. So that has become a criteria for acceptance by clients. So yes, while we do have our own vessels, not generally all the time it will be available to us. And for me to select a vessel, I would select the bollard pull that I need, and I would put it through a technical bidding evaluation. My commercial side will do a commercial bidding evaluation. For commercial, it's very simple. They compare everything. Cheapest, good. For me, the good, what do you call it? The location good, the higher, what do you call it? The reputation of the thing good, and also, my warranty surveyor says it's acceptable. Those are my technical bidding requirements for my side. So that answers when we're going under charter. Okay, so I am allowed to charter other vessels, provided I do a CBE and TBE. They will go through a list of items that need to be checked off. Is there any special, Nur Hafiza has asked, is there any specific weather limit for towing operation, rig move operation? What kind of mitigation done if weather suddenly exceed limit? Okay, good. That's a very interesting question. All right. When I set the limits for our tow operations, I usually require a 4-day good window. 4-day good window for a tow to commence or anchor handling to commence. Now, what happens is you can only mitigate so much, because otherwise you will never find longer windows in the whole ocean. So why do I say 4-day good window? 4-day good window is because if there is no 4-day good window, I cannot start. When I start, I cannot stop. When I have started removing all the moorings of the rig, I have come down to less than ideal, no longer under the mooring analysis conditions. So when I'm in that condition, I try to mitigate it to about 4 days. I try to make sure that I can finish off my anchor handling in that under that 4 days or time of operation, so that I can start my tow. When I am on tow, if I'm under, they will say I need to have a minimum of 2 days, twice daily weather forecast, 7-day outlook, twice daily weather forecast, and that would be able to we will be able to plan weather routing for the passage. So now let's say you're asking what type of limitations am I looking at when I'm towing. So for me, the dry tow, it is 10 degrees. If anything rolls beyond 10 degrees, I need to alter course, alter speed, and stem into the weather to prevent parametric rolling or rolling, the rolling that just increases in velocity and in amplitude. For my rig, when I am wet towing, I have a 6 degrees double amplitude tow. So if I'm rolling like 3 degrees, 3 degrees, 4 degrees, 4 degrees, I'm starting to roll very badly, I would abort and head into the weather to stem. So why do we stem the seas is the same as any vessel. When you at the longitudinal to the wave, what happens is the wave right through you. You are harder to pitch than you are easier to roll. When the wave length is the size of your breadth of your vessel, you roll very easily. But when you're riding it through longitudinally, what happens is it rides through, and the crest and the crest of one wave to another wave set rides through your vessel. You don't roll as much. Whereas if you were sideways, a vessel can be about 93 meters long, 100 meters long, but it's only 20, 30 meters wide. You're less likely to pitch than you are to roll. So when you are in rough weather, beyond this, when I see that I'm starting to roll about 6 degrees, I would alter the lead tow, lengthen up the wire. Why do I lengthen up the wire? So that we are not on the same or on different periods of swells. I lengthen up the wire, I slow down the speed, I lengthen up the wire, I alter the course and ride into the sea so that it reduces the stress on the towing wire. So if it exceeds limits, I would alter course, head into the sea, lengthen the tow wire between us, and ride through the system until the storm passes. Then I can continue, shorten up, and continue again the operations. Does that answer, Nur Hafiza?
So it means that there is no specific such as wind limits, wind speed, 30 knots, 50 knots cap?
Okay. No, there is no limit to that because my rig itself, I'm capable of operating up to 70 knots. I can survive up to 70 knots.
Oh,
But the tow wire, 70 knots. But the tow wire itself has a MBL of 400 tons. But the vessel pool itself doesn't have 400 tons or bollard pool. So in that sense, what we're doing is we're mitigating tension on the tow wire by lengthening the wire. So at the end of the day, when you slow down and when you have a long wire between each other, the shorter the wire, the more tension, the stronger the stress between the two bodies. The longer the wire, you are relaxing the what you call the period of stress on the wire. You will have less tension on the wire. Okay, good. Hafiza, that's answered. Okay, so we have talked about process safety, towing. We have talked about process safety for rig moving. I'll bring it down to the ground. I'll share with you a video on hazard identification. So all these are very, very big words. All these are very, very big words when you talk about the, from the process of Petronas's and Shells and all that, when they talk about the big HSE groups, all these words that they're using is so big. How do you translate it to the guy on the ground? You're talking about the company that hires the brightest minds in Malaysia, but to execute it, we have got to put it down to the lowest common denominator, the man on the ground whose hands are on the shackle. The rustabouts, we're talking about the seaman, the ordinary seaman. They have a lot of experience, but it's ground up punya experience, bukan dari sekolah punya experience. But how do you bring those type of messages in to make them work safer? All right. I will answer your how long does it take to position the rig shortly. For me, the guide, when I'm in the location, I'll just answer this question before I go into hazard identification. How long does it take to position the drilling unit to the designated position? Once I've arrived at the location, anchor, because I'm running out about 1,200 meters of anchor, each anchor takes approximately 3 hours to run, each anchor. If I have a midline buoy to install, it adds another 1.5 hours to 2 hours. So we're looking at anchor handling operations could be anywhere from 24 to 36 hours of anchor handling operation. Generally, I would recommend 2 crews, 2 sets of crews for the boats, 2 sets of crews for the rig in order to cover a 24-hour operation. Otherwise, if the drilling team says, okay, no, we're going to save money and we don't care about time, you can do as much as so what we need to do is we do 12-hour shift, add on another 4-hour overtime, then we stop, rest for 8 hours, start again the next day. There is an option to that. But usually when you're in this type of mobilization, as I said, the platforms don't like it when they shut down very long. The longer they shut down, they lose a lot of money. They lose a lot of time. Their time is money for them when you're talking about shutting down platforms. So when we are doing rig move, anchor handling, over pipelines, heavy lifting and all that, they want to shut down as minimal as possible. So they are usually willing to absorb the cost of double crew, 24-hour crew on the rig, 24-hour the vessel, in order to make this operation happen. So yes, it takes anywhere from 24 to 36 hours to get all anchors run in the position, provided you have one single anchor pattern. Some rigs require you to do one single anchor pattern for lifting, and then demob another 24 hours, 48 hours, come back in another 24, 48 hours to run again in the drilling position. Lifting position and drilling position could be different for some rigs. So it totally depends on what type of operation you're running. Okay, I'm going to share with you guys, since I've talked a lot, I'm going to share with you guys a video on how to bring all this safety message to the crew on the ground. And this is something that we did for a safety video competition. It won the what do you call it, like the Academy Award for that year of safety videos. So I hope you like it. Let me share this video with you guys.
All right. Good. Cap, do you have production company? Is it?
Production company for what? For
I saw a lot of your short video in your.
Okay. Yeah, let me know if y'all can hear this.
So far, no.
Okay, enjoy.
Suddenly you're standing still. So beautiful, like an angel in disguise. But if you meet a friendly host, will you communicate by how will you speak to that?
Okay, that was our little video on hazard identification. We did that several years ago and won some prizes for the competition between all the shell rigs all around the world. Everyone come up with some safety videos. So this was our entry, and that won some prizes there. So we hope you
Yeah.
like that. Okay.
Yeah, interesting.
Yes. Okay. So that's hazard identification that I would like to share with you guys. But before I go there, I would like to bring a sense of how should I say? Now you've seen a little bit of action, a little bit of you've heard a little bit of hazards, but
Mhm.
really to see those things put into a short the preview for you guys. When we mobilize, demobilize, what our activity that we go through, I'm going to share another video with you guys, all right? One minute, I'm trying to look for that. Maaf, memalukan saya. Tak dapat cari itu.
Okay. Take your time, Kak.
There it is. Okay, got it. Okay, so that kind of perspective that the things that we are working with, as you could see from that little video, right? Humans are very small. Those things weigh hundreds of tons. In the wrong day, in the wrong vessel, what do you call? On the wrong vessel, on the wrong sea state, things can go very wrong very fast. We always say a point of no return. If you're committed to start after you have gone through all the safety steps that we have talked about, from the rig move council to the rig move hazards to the on-site meetings to the pre-starts and everything, now you are on site to carry out this job. You have to assess at a certain point, go or no go. So we call it go, no go. How do you assess this? For me, on a lifting type of vessel, on a lifting operations, I will go, no go for me is, I will put the block in front of the OIM on the platform. If the crane operator can see this block go 0.5 meters up, 0.5 meters down, 0.5 meters left, 0.5 meters right, if he can hold it within this sphere, yes, we can lift. Because why? When you're talking about the block of a crane, right? The block of the crane is already the size of a human. If that thing is already moving like that, you can tahan, okay. Because now it's going to be connected to a 180-ton item. It is going to be 20, 30 meters big, 30 meters long, and it's going to be floating in the air in the same motion as this block. So if this block is moving at 2-3 meters up and down, left and right, you obviously don't want a 180 tons, 300 tons item moving in that manner. Because the moment you lift it up from the ground, you cannot put it back anymore. So we call point of no return, go, no go. For a lifting operation, it will be weather related. It will be the period of the sea, how bad your vessel rolls. For anchor handling operations and vessel operations, it will be how high is the maximum sea. For an anchor handling vessel, if the sea or the vessel is heaving 2 meters, you can imagine a buoy the size of a car is floating 2 meters up and down, it can crash onto the vessel and hurt the people very, very fast. Therefore, we go, no go, weather, limits, yes. For the wind, for anchor handling operation, I go with 25 knots. Why 25 knots? Beyond 25 knots, the windage of the crane cannot fight with the wind. Imagine a tower crane, what do you call this type of crane. We are at the mercy of weather. Beyond 25 knots, I cannot blow the crane cannot move, so you cannot do. So 2 meter seas for the anchor handling vessel for the safety of the crew, 25 knots because I can no longer move my crane. And for me, 3 degrees roll. If I roll more than 2 degrees, I cannot do the operation anymore. Okay, so that being said, I'm going to request that you share my presentation with them, because everything that you've watched so far, and everything that's in this sharing so far, right, is also inside the intro pack that I'm gonna share with you guys. Can you see my screen? Can you guys see my screen?
Yes, yes, that's good.
Okay, so earlier on, the preview of the offshore life is here. Exciting offshore life is here. And what I would like to leave with your team, with your group, right, is I'd like to introduce a few items or a few good sites for them to get resources. One that I like is the WSHC, Work Safety Health Council, which has a step-by-step risk management for marine industries. If you click on the link, it will bring you directly to the website. Let me just share the website. Let me know when you can see my screen.
Oh yeah.
Okay, so what this has is a step-by-step guide, which is literally a presentation by itself. So initially I was going to go through this slide, but I think if I go through this slide, it will be the morning already. It's like 50 over slides, which tells you who goes into a rig move, risk assessment, everything that we talked about, but in a point form. You know, like what is a risk assessment, what is a formal risk control measure, what is a risk register, all those things, who does what, you know, who, where for marine industries. This is a very good website with a very good guide on this type of items. And on top of that, it also has exactly what we talked about just now. When we are inside the, what do you call, rig move risk assessment, what are the hazards? What are the step-by-step activities? What are the hazards that can happen? What are the possibilities that can happen? What is the, what do you call, mitigations, existing mitigations in place? How do you risk factor it? Do you need additional controls? So these are a textbook version of what we just talked about. Who does what? How do you fill this in? What is the best way to mitigate it? This is a very good website with resources on this. And I would like to really like you guys to look at this website. In Malaysia, there's supposed to be NIOSH and all that, but its content is not as good as the WSH Council. The WSH Council is a really good resource. So another one of the resources that I like to share is the WSH manual for marine industries. So when we talk about this risk assessment and all that, right? Where is the quantifiable, what do you call it? How do you go step by step? Is there a guidance for this register, or do I have to come up with it myself? So when you go into this website and click on this link, right, what happens is they will bring you to a WSH site, and it will provide you with a manual. This manual literally comes out with a breakdown of activity. It's like a risk register, master risk register. If you're going to work on scaffolding, on offshore activities, what are the things you need to for? What are the things you need a guide for? They step by step come up with mitigations and all this stuff. It's a very good resource for your students. And then, sorry. Yeah, there you go. So this is the work safety health marine industries. So it is 230 pages long, which has evaluation, work permits, everything. And then it goes down to all the way to what do you call it? Activity itself. Activity by activity, it will tell you what are the things that you need to look for, what are the things you need to look for. Breakdown of activity for shipbuilding, for whatever, when you need to have meetings, when you need to have and you know, what are the code of safe working practices for good stuff and all that sort of thing. What are the risks involved? How do you break down the risk? What are the type of things? Let's say you want to load machine with paper roll. What are the type of hazards that come through risk evaluation, risk control, and all something? So it's a very good resource for these type of things. It has all these already made up for marine industries. So it's a very good resource for your students. They've gone beyond. They've gone beyond the what do you call it, the normal NIOSH and you know, like safety divisions. They literally did studies and all that, and they come up with tons of references, risk ratings, pinch points. How do you do this when you want to remove mounting bolts? What you need to do? Literally, it goes down to, they have the process for you. You just have to fill in. I'm going to do this. I can take out this activity. You can even use this as a reference for your own risk assessments. So this is a very, very good resource location for these type of things. Another good, so inside my presentation pack, I've also come up with the WSH safety posters location. So what happens is when you go into the WSH page, right, they also have resources where you can select what do you want. You want case studies, you want articles, you want codes of practice, guides and handbooks, resource kits, even safety posters. So they've really gone beyond the, what I call, it's the national part of it. They've done their work. So you can even just print out this straight away, use, post it on your ships and all that. They allow you to download. It's all free. Work safety and health has no proprietary what do you call, oh, this is copyright. No, it's all free. Use it. Any resource is available for you to use. So I love this website. I love this. It goes by topics as well. Let's say you say confined spaces. You take confined spaces and everything that you want under confined spaces will come out. Know your confined spaces, your work boards, this and that. You want to say, I want resource kits. I want training. I want guidelines. I want guides and handbooks. What codes of practices? Everything that you click under that will come out. So I would like to really share this, bring this up. Asbestos, chemicals, cleaning, compressed air, by program, you know, by industry. You go under whatever industry you want. Languages. That's the best part of Singapore. They have it in Bengali, English, Malay. So if you have crew of different languages, you can even print out different languages, and you're guaranteed that it will say the same thing, not come ride a camel and sit on a cow and all kind of thing. So it's a very good resource site. I've included in my presentation pack. Please share with them. And
I already shared in the chat section.
Okay, excellent. And the last thing is I am active on this. I'm active on Facebook, and an operation. I do an operation in. If I do an operation on what do you call it? If I do an operation on the rig, I would update this link with everything that I have, sharing pictures, motivation, how to do this, how to do that. Generally, what we have learned is in the past, in today, right? If you were to look at seamanship, people are still referring to Denton's seamanship, written in 1963. If you talk about oil field seamanship, the guys are looking at this seamanship series, oil field series, written in 1980 something. 1960 something, 1980 something, 2000 something, you know, we're talking about 100 years of difference already. You know, 50 to 100 years of difference, where they're still talking about tackles and flies. You know, we don't use derricks anymore. Nowadays,
Yeah.
people use mechanical cranes. You're talking about hydraulic cranes, electro-hydraulic cranes. So I try to think about it as a give back to the society. Everything that I have come up with, experience, lessons learned, things that we can share with the industry to make the industry safer, I have put inside here. I have 82 topics that I've written out. Please go and reference it. If you have any doubts or questions, you can always contact me on Facebook. That link brings you to my sharing 82 topics there, and also my own Facebook page in case you all need to get in touch. Yeah.
Thank you, Gap. All right. Okay.
Yes.
I already shared all the links that you mentioned earlier in the chat section.
Yes.
So those participants can click or save the links directly from the chat section. Okay. All right, Cap.
I'll also add,
Do you have
also
anything
add the-
to share?
I also add the
All right.
YouTube links to all the videos that we saw just now, so that you all can also use that as a thing when you all go and become lecturers and teachers and all that. Then you all have
And-
some resource to do that.
And please subscribe. Cap.
Like and subscribe. Yes.
Let's subscribe.
Okay.
Okay.
So
So
I
I-
open the floor.
Yeah,
I
from
open the
the
floor to
participants,
questions on your side.
some of the participants are also among the staff. I see a few staff here, or even alumni. Some of from the alumni. Okay, any question from those guys? From you guys? You can write in the chat section.
Yeah, don't be shy. Actually, just show your face and talk, man.
Yeah.
You're all
Now
gonna
you
be
can ask
to the
any
industry someday.
question regarding the career or whatever that you think related to our discussion or our topics tonight.
Jangan malu-malu. Saya juga boleh berbahasa Melayu.
Oh. Okay, Joseph.
Okay, so when you see the risk hazard identification video just now, inside that hazard identification video, I have peppered in with all the industry tools that are available right now. Compliance, intervention, action. We're talking about 7 steps of safety, 4-point checks. All have been peppered out inside the. These are currently the industry tools that we have. In my company, we use something called PBED, as I've explained: planning, briefing, execution, debrief. 4-point check is what can go wrong, who needs to do, where is the hazard, and all that thing. We have something called energy wheel prompts. Energy wheel prompts are literally all the different type of energies that can come up and become hazards. It is included in a lot of our nowadays all the what do you call it, the JHAs, job hazard analysis forms, or the hot work, cold work permits itself.
I see.
Will also have these hazard prompts included. So if you're talking on site, the simplest version is the JHA or the TBRA. We call it TBRA, task-based risk assessment. Literally, bring yourself, put the steps down, identify what are the steps, identify what are the hazards involved in these steps, what are the mitigations in place, and are there anything that you can do to, 1, reduce the effect of this, 2, eliminate. So you got the 7 the hierarchy of controls and all this other thing. But at the end of the day, when you come down on site with all this, you got a risk register which comes up with a master list. you got a risk assessment, which you list down your steps and how do you prevent these things from going wrong. But on site, once you reach there, you still have to do your due diligence to look for things that are now out of the ordinary, that are not in written down into your JSHA. So we also have something called timeout for safety. Means that if let's say there was something that didn't go according to plan, something that is wrong, something that came up, we'll say stop for safety. We need to regroup. We discuss how to mitigate, correct it, and go forward. So these are some of the tools that are in the industry, because all the big words that you learn in university, where you talk about bow ties and all this other thing, these are captured in the HSE case. HSE case, which is corporate-wise, government-wise, and all that. If these things go wrong, how do you mitigate this? What are the barriers that you need in place? So, how do you translate this to operations? Very simple. We take the critical barriers and make them into roles. We put the people or the process as barriers and make checklists. And so, for instance, on the rig, right? This is Zaida. He is the ballast control operator. So on the rig, we talk about stability. He is the caretaker, custodian of the stability part of the critical process. So he is the critical barrier. We make sure that there's 24-hour coverage. We make sure that he has the tools that he needs. We make sure that he has the checklist. We make sure that he has the stability checks. He does his things that he's supposed to do so that the rig does not sink. Likewise, with well control, you have people who have IADC well control certificate. You have people who are of a certain qualification. They know what to do when when the annular comes up, the annular pressure is more than whatever pressure. When do you kill a well? What are the if there's a fire? Who is the fire team member, fire team leader? Who does this? Who does that? What type of scenarios in emergency response? Everything has been tabled out as tasks, as persons, as job scopes. But actually, every one of this is a component of the original bow tie. We are the custodians of those critical barriers that were originally in the bow tie. So how do they translate that? They take a bow tie, they break down into all these parts, the barriers, mitigation, they further break it into roles, take all these roles and put positions into them. So everybody, I know you are now in charge of this. Anis, you are now in charge of this. Ashraf, you're in charge of this. You're in charge of this. Broly, you're in charge of this. You make sure that you follow your checklist every day and you report to Cindy. You report to Cindy. Cindy, you are in charge of all this. So when you have supervisors on top of these processes become the physical embodiment of the bow ties, of the HAMPs, of the hazard effect management process, all those things that you put into safety case, all those, the mitigations, all those analysis and everything, you now physically become the barriers. And on site, you have your JHA, JHA means your job hazard analysis or job safety analysis, your permit to works, your checklists and everything as your safety tools. Does that answer your question, Joseph? Or you need more clarification? Actually, just switch video and your voice and talk, man.
Yeah. Cap, regarding the hierarchy of control for offshore industry, like normal maritime industry, we use 5 level of control. How about you mentioned just now 7 level of control. So which
depends on process safety. Let's say example, process safety for oil and gas may be more layers. So there could be elimination, there could be isolation, there could be other things. Different industry practices different layers of hierarchy of controls.
Indeed.
But all these are all still lingo. So let's touch on earlier on when we when you engaged me for this, right? You wanted to talk about ALAP. So you have controls, you have procedures, you have processes, you have industry safe guidelines and all that. Everything that I've said so far, you can find in the WSH website. But let's say you are in a gray zone. Now you have to come to experience. You have to come to industry experience, your corporate memory, your corporate process and procedures experience, things that you have done before that is not done before in the whole industry. There's no other references. How do you bring things to Alap, where the risk is brought to as low as reasonably practicable? So no harm, no cure, no hurt, and all those other things. Using all the processes, using a simple risk assessment, your address of what can go wrong. How do I eliminate this from, can we eliminate this process? Can we totally not do this at all? So you go down your hierarchy controls. Your hierarchy of controls is now brought into practice. Can we avoid this task altogether? Is there a better way to do this thing? If not, how do we substitute or isolate the danger away? You know,
Yeah.
so we're talking down the controls, and of course, the last layer is when you're on site, then you tell them, hey, please wear helmet, please wear safety glass, please wear your
Yeah.
earplugs, please
All the
wear
PPE.
your safety gloves, all the PPE. But processes are more important. PPE is the last level of defense. Don't say PPE is not important. PPE is important, but the last layer of defense. So as you can see in the video that I have made for the hazard identification, right? You start the job by identifying what can go wrong. What can go wrong? Can we do this in another way? Is there any other way to do this job? You know, go down your hierarchy of controls. What can we do to... So it's not a one single answer. When you have a hazard identification process, you have a team with you. Hey, apa boleh berlaku? Apa boleh orang boleh jatuh? Ini boleh ini. So usually you can have a safety officer with you. You have the work site supervisor with you. You have your work team with you. Go through the process, or if you already have a hazard register JHA, then you bring it and make it live. Okay, kita akan hari ini kita akan berbincang pasal ini kerja, kita akan buat ini apa itu. Okay, ini can you, then you ask them, you prompt them. Apa boleh berlaku? Okay, kamu akan buat apa? Okay, apa yang kamu akan jaga? Mana boleh tangkap api, you know, mana boleh menyala? Apakah benda yang perlu kita so you go through step by step with them, make sure that they understand it. Because when it comes down to on the ground, you have to simplify already. The biggest processes, bow ties and all that, forms the what do you call it? Forms the procedures, the directives, the processes that guard the activity. But when you come down to the very simple one, it's JHA, TBRA, permit to work, isolation certificates, safety checklists, things that are in your hand, 4-point checks, compliance intervention. You know, stop the job. You have the right to stop the job, empower them. You have the right to stop the job if it's not safe. Attitude, compliance intervention and attitude A. Why? If somebody stop you and then you, hey, jangan bising-bising lah, aku nak buat kerja ni, biar aku suka. Attitude is not there. Then you fail the process. So it becomes behavioral safety also comes into play. You know, so there are many processes. If your company has money, they will put money into hearts and minds, into you know, safety culture and all this sort of thing to process to bring the culture into play. Because at the end of the day, when you see the trend, if you don't have a good culture, you're not gonna have a good trend.
Indeed.
And KPI.
Okay. All right, guys. Okay, Cap. Thank you.
It's 11 o'clock.
Okay. So before I stop this session, allow me to share 2 of my slides, my last slides. Okay, allow me. Just give me a few minutes. Okay. Okay. Other than become a expert in rig mover, okay, Cap also a part-time actor, Cap. Okay. Okay, other than that, I just found in his Facebook, he's he got a very good heart, okay, in helping the people outside there, especially during the COVID-19. Okay, thank you, Cap, for sharing this. Okay. And not only to human, he also have a good heart to the animals, cat. How many cats do you have, cat, in your house?
Oh, my wife rescues cats. She has 26 cats, 2 dogs,
26.
and fishes.
Oh, yo.
All of these cats are all rescued from longkangs or from somebody's engine or the mother died already.
Right.
Nobody take care of them. They're young. Nyaris, nyawa ikan and all that. She save up. Each and every one is a safe.
Yeah.
What do you call? A creature story.
Yeah. You and your wife have a good heart, cat. Well done. Okay, guys. Before we ending our session, allow us to. Can you open your video so that we can have a quick photo sessions, please? Anyone? Semua, kau boleh buka video kejap, kita buat photo session. Okay,
Jangan
please.
malu-malu. I know it's 11
Jangan
o'clock. The
malu-malu,
women all
kawan.
don't have makeup, but it's okay. Don't worry.
Some more, guys. Ke dah bangun tidur ni. Okay, I'll take a photo. Okay. 1, 2, 3. Okay, 1 minute. What? Oh, okay, okay. Are we waiting for others as well?
More people are coming. More people are coming.
More people are coming. Come on. Hurry up.
Yes, jangan malu-malu. You all can put on Facebook, man. Saya pergi kelas sampai pukul 11. Cikgu paksa.
Dia orang suka kelas lewat malam ke?
Oi, okay.
Okay, control. Okay. Ready, yeah? Yes. 1, 2, 3. All right. Thank you. All right. Thank you so much, Cap. Maybe we have other session next time. Thanks for your sharing. A lot of knowledge that we got from you. Thank you for your links for all the materials. Okay. Maybe some of other participants want to follow Cap. Please follow his Facebook, and then you can have a conversation there. Okay, if you have any other
Yes.
questions.
When you add me on Facebook, just put there UMT. UMT, then easy for me to know that you're from this class.
All right.
Add me on Facebook, no problem.
Some
Use the
statistics
links.
for tonight. We have the highest participant that we have for tonight is 72, if I'm not mistaken. So now boleh bertahan sampai pukul 11 sampai end of the session 54 ni quite a good number lah. Okay, thank you guys for stay with us. Alright, thank you so much. See you next time in our
Okay, thank you very much. Okay, thank you very much, you guys. Have a good day ahead, and
Okay, thank you.
all right, thank you. Thank you. Good night. Thank you. No problem. Welcome.